This is my circuitry for the water monitor robot. So starting with the sensors, we have the potentiometer here, which acts as a proxy for the pH sensor. Realistically, this would just be your normal pH sensor submerged in the plant tray, which is then read by the software. And then we have the photoresistor here, which is a proxy for the EC sensor. This determines how many nutrients are currently in the plant's water. Next up, we have the tray water distance sensor. This just detects how much water is in the plant tray where the root sits. Next up, we have the water tank distance sensor. This just detects how much water is present in the external water tank, which is used for refilling the plant tray. And then here we have, just like the water tank distance sensor, this one is for the nutrient tank. So this will refill the plant tray with nutrients when needed. And both of these tanks have DC motors to act as pumps here and here. And then finally, this is just the LCD here, which we're using to show the user any relevant information. Now I'm going to go ahead and start the simulation here just so we can see how this all works. So once the system starts, we should get an output line here like we did, and it's immediately going to run through the algorithm starting with the water, then the pH, and then the nutrients. As we can see here, it detected that the nutrients were low and refilled it. So this is just going to keep continuously running through trying to determine any problems, and if they do arise, then it'll solve them in these different various ways. Now, the first thing that can happen here is if the tray water level is too low. It'll immediately detect this and say it's refilling the water. The pump turns on and starts the refill process of the plant tray. And it'll do this over and over again until it detects it has enough water. So like we see here, the motor turns on, refill is complete, it goes back through, checks the water sensor, and if that's good, which we are, we're above the 75% threshold, then we will continue on throughout the algorithm. The next issue we check for here, right after the tray, is whether the pH level is within range, which as we can see here, it was 8.10, which is outside of the range that I stated earlier. In this case, the system does not do anything, it just alerts the user. The next issue is whether nutrients are outside of the range or not. So I'll go ahead and change this down all the way to 0 here, and then it should give us an alert that nutrients need to be refilled, which they do. The motor runs here, refill is complete. Next, we will go ahead and start the loop over, go back and check through. If it isn't, if it does need refilling, then it'll go ahead and do that until it is full, which we can see here once we run back through the tray level, the pH, finally it's back to normal. So during this refilling process, there's one problem that could occur, and that is if either of these tanks are completely dry. So we'll go ahead and simulate that here by raising the tray up to outside of the optimal range, reduce this down, and then it'll say alert external water tank 0%. So that indicates it needs a refill from the user. And this same thing is apparent here if I go ahead and move this back for the nutrient external tank. So if I go ahead and raise this up really high, go ahead and reduce down the nutrient concentration, we will see here that there is nothing left in the nutrient tank, as we can see from this alert here. So now we're just going to take a quick scroll through the code here. I'm just defining all my variables for pin numbers up here, some variables for the tank heights here, and then here is our setup method where we're just setting the pin modes and turning off the motors and initializing the LCD. This is the refill tray method, our main loop, get tank level, which just returns the water level as a percentage, read pH, and then read EC. Thank you so much for watching.